All right, hello everybody. In this recorded video, I'm going to review line angle, or in other words, skeletal representations of molecules. As we discussed, a lot of organic molecules are carbon-based, and this is a way to simplify drawing the carbons and the hydrogens bonded to carbons in organic molecules. Chemists use this in the primary way that they communicate molecule structures. So I'm sure if you completed the bonus assignment, you saw line angle representations of molecules. Your challenge homework has a line angle representation. So this is really commonly used, and again, it just makes drawing molecules a little bit more simple. So I'll start with an example. We'll talk about naming later in the term, but I'll just state the names of these molecules. So this one is propane. This is a molecule with 3 carbons in a row, and then each of these carbons is bonded to enough hydrogens to complete their octet. So the central carbon is bonded to 2 hydrogens, and the carbon on the right is bonded to 3. The line angle drawing of this molecule looks like that. So much more simple. You got 2 lines instead of many more. So the shortcut, I'll write this line here or these lines to indicate these 2 molecules are the same. The shortcut to drawing carbons and hydrogens bonded to carbons. And that's what this line angle representation is. So the end of a line angle representation, so I'll highlight that here in pink, the end represents a CH3 group, or a carbons at the end with enough hydrogens to complete its octet. A carbon and sufficient hydrogens to complete carbon octet. So in this case, that where I highlighted in pink is a CH3 group. So that is this whole part of the molecule is represented by the end, the left side of that. And then a bend in that corner also represents a carbon and sufficient hydrogens to complete its octet. So in propane, that center carbon, this bend right there that I highlighted in blue, light blue there, represents the central carbon and enough hydrogens to complete its octet. In this case, it's a CH2. Then in the representation, the only other thing we have is that end of the chain, and again, that's a carbon and enough hydrogens to complete its octet. So all that's drawn here are the 2 lines that show the 2 carbon-to-carbon bonds. Let's highlight that in yellow. So 2 lines, 2 carbon-to-carbon bonds, and then the end represents a carbon, the bends represent a carbon. So let's do another example. This one will be pentane. So pentane has 5 carbons in the chain. And then enough hydrogens to complete each carbon's octet. So CH3, CH2, 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 CH3. We can simplify this using a condensed formula. which is CH3, CH2, 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 CH3. So that's another way to represent this molecule pentane. So it's a condensed formula, and we can draw the line angle drawing. So we have, if we start left to right, we've got a CH3, then a CH2. So represented here, another CH2, another CH2, and a CH3. So I'll also highlight what's going on here. So the end, carbon, and 3 hydrogens. Next we have carbon, 2 hydrogens. Then we have carbon and 2 hydrogens at the next bend. Then carbon and 2 hydrogens at the next bend, and a CH3 at the very end. So the ends in this case represent CH3s, which is common, and the bends represent CH2s, which is common. Now if we add a double bond in this structure, so let's do carbon double bonded to carbon, so carbon on the end gets 2 hydrogens. Now instead of drawing the Lewis structures in a straight line, I'm going to take into account the geometry. So we'll space the carbons and hydrogens out a little differently. This will be a 4-carbon chain. And the skeletal drawing here, we have a 4-carbon chain. So instead of highlighting, I'll use numbers. We have carbon 1, 2, 3, and 4. 1, 2, 3, and 4. And then we have a double bond between carbon 1 and 2. So that is the line angle drawing for this molecule. Let's do another example. If we have a ring, let's say we have a 5-membered carbon ring. So 5-membered ring. Each carbon has 2 hydrogens bonded to it. Well, we use the line angle drawing mostly to represent spacing of carbons. We've got 5 carbons in that ring. So line angle drawing, pentagon, 5-cornered ring with carbons 1, 2, 3, 4, and 5. So that's all that we draw is what I've drawn in black there. But what this represents is this whole Lewis structure. So even though we don't draw the carbon atoms or draw the actual H to represent hydrogen, it's implied that that's part of the structure. So we need to know by looking at a Lewis structure that if we have a bend, so carbon 1 is at a bend, carbon 1 is shown with 2 bonds to other carbons, then we can see that this implies that there's 2 bonds to hydrogens. We'll do 2 more examples in this video here. So let's do an example without all carbon. So we'll add an oxygen here. So we'll have, now I'm going to use a condensed formula. It's good to be able to use all of these. So we've got a CH3, oxygen, CH2, CH3. Well, the bends and the ends in a line angle drawing only represent carbons and hydrogens. So when there is an oxygen, we have to draw that oxygen out. So let's start with where the oxygen is. That oxygen is bonded to one CH3 group and then a CH2, CH3. We can add in lone pairs as well. So at the end here, this represents a carbon. That's carbon 1, that's a CH3. Then atom 2 is the oxygen. Atom 3 is a CH2 that's represented by the bend. And 4 is a CH3 represented at the end. So anything other than a carbon or hydrogen bonded to carbon needs to be drawn out using the element symbol. Last one I'll do here is a molecule with nitrogen. So we'll have CH3, CH2, CH2, NH2. Well, starting left to right, we have 3 carbons. So this represents 3 carbons. 1, 2, 3. 1, 2, 3. And then carbon 3 is bonded to a nitrogen. So we create that new bond to the nitrogen atom. We have to draw the N. We also need to draw the 2 hydrogens bonded to that nitrogen. So anytime you have a hydrogen bonded to an atom other than carbon, those hydrogen, the H's, need to be drawn out in the structure as well. So this is 4, we have 4 there. Let's do one last one. One more. We'll do a ring. So we'll do CH2, oxygen, CH, double bond, okay, so maybe pause here and try drawing this as a line angle drawing on your own. And I will draw it in the video, but again, if you want to pause and try and then watch the video, that's a good idea here. It's helpful to count atoms like we've done, so I'll just start at the top. So 1, 2, 3, 4, 5, 6. So this is a 6-membered ring, and one of the members is an oxygen. So I'll go ahead and draw that oxygen in. I have 1, 2 carbons, now 3 carbons, 4, and 5 represented. Draw in electrons. So now we have all atoms, all carbon and the oxygen atom represented. The only thing that's missing, well, let's go, well, it's number. Carbon 1 is a CH2, so that's good. 2 is the oxygen, that's good. 3 is a CH2. 4 is a CH. 5 is a CH, and 6 is a CH2. So the only thing that's missing here is that double bond between carbons 4 and 5. So we have to add that into the line angle drawing as well. So main idea to keep in mind is that if you see the end of a line or a bend, that represents a carbon with enough hydrogens to complete its octet.